and this is the product of the two vectors. We call it a scalar product, we call it a dot product, we call it with another name is inner product. When we will discuss it in component form, then we will see that the inner components are being multiplied, and due to that reason we call it as an inner product as well. So this thing that A dot B will be equal to B dot A. Similarly, if I will be having A dot, like the dot product between a vector and then two other vectors are being added, then it is the same if I multiply A is a dot product with B, and then I add with when A is multiplied as a dot product with C. Like it will be the same if I add them first and then multiply as a dot product, or I find the dot product of the individual vectors and then add them up. As I see here that A is distributed with B and C. So this property I call is a distributive property. It's a distribution. So it's a distribution. The dot product is distributive as well. Now if I'm having two same vectors, like means A dot B is equal to this. So if I'm having A dot A, now from here, from the definition, from here A dot A, so it will be the magnitude of A and the magnitude of A, so it will be equal to A times A, just numbers, so there is no dot between them, it will always be between vectors, and cos of the angle between them. Now if this is vector A and the same here vector A, so both are the same vectors. Vector means it's the same vector. Its inner product or its dot product with itself. Now what's the angle between the two? I will translate it here. In order to find the angle between the two, I will just overlap it here. So they are in the same direction and the angle between them is equal to 0 degree. And I know that when cos 0, so cos 0 goes to 1. And I will have that A dot A is equal to A squared. Just like numbers. If this is 2 in magnitude, 2 in magnitude, so this will be equal to 2 square equal to 4. And if I consider the two vectors like this, that let's say this is vector A and another vector which is vector B is completely perpendicular to this vector, means their angle is 90. Now, how much is the projection of this vector along this vector, like ABX? So this one is not having any x component. Its x component is equal to 0. And due to that reason, ABX will come out to be A times 0 and then the angle between them. Similarly, if I make it the other way around, like B dot A, so the AX component is here. This is the A, and when I resolve it into components, then it will have its X component equal to 0 on B. So the A vector is having no projection along B, no contribution along B. Similarly, the B vector is having no contribution along A, and due to that reason, I will say that A dot B will be equal to 0 if their angle is exactly 90 degree. then they will have no projection on each other. I say that they are perpendicular vectors, and in that situation their dot product will be equal to 0. Their their multiplication their multiplication is a dot product. It will result in nothing. Like when I'm finding, for example, area of a square or area of a rectangle. Let's say this is a rectangle. Now this is side A and this is side B. Now what about the area of this rectangle? The area of this rectangle is A times B. But if I say that this is vector A, these are just numbers. That's why I just multiplied this, although the angle here is 90, but they are just numbers. They are not vectors. If I consider them vectors, then I will write this thing is vector A and vector B, and then their dot product will be equal to 0. So A square here, a square, does it possess the dimensions of area? The answer is no. It is not possessing the dimensions of area. Because the area concept we will cover in the cross product. Over there the area concept comes in. A dot A or A dot B is not giving you area. So let me let me solve the example 1.1. So this is example 1.1. Example 1.1 says that let C is equal to A minus B, which is shown in figure. Calculate the dot product of C with itself. So it is have been shown here in figure 1.7, and 1.7 figure is on the other page here, and this shows that we are having vector B here. This is vector B and this is vector A, and the angle between them is theta, and another vector which is vector C in this direction, like B, C, and then A like this. So we are having this is vector C. This tells us that B plus C, B head to tail rule, B plus C is equal to A, and from here I can write that B is equal, the C is equal to A minus B. Now the question is here that C is equal to A minus B and find C dot C. So C dot C will be equal to the value of C is A minus B and then dot and again A minus B here. So let me find out this thing. First, is it is dot product is distributive, we have set here. So A will be first multiplied. A is a dot product with A minus B and then minus sign here and B here, and it is with a dot product with A minus B here. So this is equal with this is A dot A minus A dot B and then minus here B dot A, and minus minus becomes plus in B dot B. This is equal A dot A. We have calculated this that A dot A is A squared minus A dot B, and we have said the dot product is commutative, like B dot A is equal to A dot B. So I can write this is A dot B, and this will become 2A dot B here, and plus B squared. So this is equal to A square, means here C dot C will become C squared. This is equal to A square plus B squared minus 2, and A dot B is equal to AB cos of the angle between the two. And this we call is the law of cosines. This we call is the law of cosines. Because from here we can write further that if we replace, means the alphabetical order like this, that if this is C and C is A and B, C square is A square plus B square minus 2, and then AB, these two, and the cos of the angle between the A and B. Now if I write this one, this is B plus C is equal to A. I have written C equals A minus B. If I write B equals A minus C, so it will be B square, it will be B square, and this will be equal to A square plus C square minus 2AC cos of the angle. Similarly, A square will be equal to B square plus C square minus 2BC cos of the angle between B and C. So that's why it is called is law of cosines. And till this point, I think it is sufficient for the dot product. And now we will start with the discussion of the cross product. But before going to the cross product, let me say few more things about the dot product. We know that the very good example of the dot product is work. Now work is equal to F dot S. Like work is force multiplied with the displacement is a dot product. So this is equal to F and S and cos of the angle between the two. Now why we have written a dot product here? Because I apply force, and this force then causes movement along S. Like I apply force, so it is the result is I apply force, so let's say it moves 2 meters in this direction, and whatever my force will be, it will give us some work. And if I go in this direction, means I apply force in this one, so if it is a this is along this way, along that way, the result will be the same. So that's why we say that it is a scalar quantity. It doesn't need any direction. When I say that I have done a work equal to, let's say, 10 joule, then it is sufficient information. I will not be asked in which direction you have done that work. So work or energy is not based on direction, is not a vector quantity. Now this is F and S like this. I can now discuss that this one, the F and S. So if I write this one, if the angle between the two is 0 degree, then I will have it equal to Fs, and it will be the maximum, because if I consider this theta between 0 and 90 degrees, then at 0 this cos 0 is 1, at 90 cos 90 is 0. So it means our work will be due to cos theta. Cos theta will then go between 0 and 1. When it is 90, it is 0 and it is 1. So cos theta oscillates between 0 and 1. So our work will be maximum if angle is 0, and our work will be minimum r 0 when angle will be equal to 90. So this is the we have to see here. Let's say, for example, this is a body, and if I'm moving it, the body is moving in this direction and the force is exactly in the same direction. So the angle between the motion, the path, and the force, it is equal to 0. It will be a maximum work done. And if, for example, this is a body and I'm applying a force in this direction, the body wants to move in that direction, means it can be moved in that direction. Let's say it's on the surface of a ground. So then our force, we are applying force, but it is not being moved, means the work done is equal to 0 in that case. Now what if I consider the example of a crane? The crane is lifting something up. So look there, that when the crane lifts something up in this direction, for example, and this is a mass which is being lifted up. So look here, this is the force is in this direction. This is the force. And the displacement is also in this direction. It is also in this direction. So that's why maximum work is done in that situation. So it is not like that here or here. The distance and the f, they are in the same direction. Another very basic question in this regard is that work is equal to F dot S, which is Fs. Cos theta is dimensionless, F is Newton, and S is meter. So we define this as joule. So work is Newton into meter in joule. But if I consider, as I will discuss in a while in the cross product, the example of torque, which is F cross S, and that will also be Newton into meter. So whether we will call that one joule as well or not. So we will discuss that in the case of cross product.